Okay, now that we've talked about ionization, let's think about ionization potential. And so what that is that's the energy required to remove one electron from some species A, which causes oxidation to the n+1 state. Okay? So in other words, it's the energy that's required to remove an electron from the atom. So if we wanted to put this perhaps in a little bit easier to grasp terms here, right? We could say if we had a hydrogen atom, right? If we had a hydrogen atom, right, it'd be the energy required to ionize the hydrogen atom to a hydrogen ion, hydrogen positive ion, and ejection of an electron. Okay, and so conceptually, what does this mean? So let's go back to thinking about the Bohr's model, okay, of a hydrogen atom. So if you remember, right, the lowest energy, the ground state, is going to be n=1, right? Or the electron. If we have an electron there, then that's going to be in the ground state. So it could be in n=2. If we excite that, n=3, n=4, and so on. All right. At some point, right, the energy levels, right, are going to there's going to be an n=infinity level. Okay, right, which collapses to some energy limit. Okay, which is going to be the energy in which, if the electron exceeds this amount of energy, it'll be ejected from the atom. So, in other words, if we surmount this energy, if we add enough energy to the system by some means, it causes the electron to go past have enough energy to go to the n=infinity level. Right. This is our ionization energy. Okay, and so if you look at the slide over here on the board, what you see is a schematic that shows the periodic table and the relative ionization energies, where a darker purple means that the ionization energy is higher, therefore it requires more energy in order to ionize that atom than something that has a lighter purple or is closer to the color white. Okay, and so we see some general trends, and we've discussed these a bit previously, right? So as we go across a period, ionization energy increases. Not uniformly, right? Again, as we've discussed, as we've alluded to before, but in general, the trend is that the ionization energy increases as we go across the period, all right? Versus if we go down a group, right, ionization energy decreases down a group. All right, and we're going to come back, we're going to go in the next couple of videos to explain these general trends as to why we see these general trends in ionization energies across the period and down a group.